In our modern-day environment, fossil fuel and liquid gas have become an integral part of our daily lives. Modern technology has made these fuels and gases accessible to all mankind, but large production processes and rapid growth have brought with them the risk of fire and explosion and the resulting loss of human life and material assets. Safety engineering and current legislation are often out of date. Statistics show us that the loss of lives and assets from explosions caused by fires or by fires caused by explosions are increasingly more common than other types of accidents. Recently, modern technology has led to the development of an effective system to completely eliminate the risk of explosion. The enormous conductivity of aluminium prevents the formation of hot points. Explosions in fuel deposits take place when a large amount of energy is released in a very short time. When the netting is employed in a deposit, the flames are insignificant. Expo Control is an aluminium alloy with which fuel tanks are filled, employing the principle of heat conductivity. This completely eliminates the danger inherent in tanks that store and transport fuel. When the netting is withdrawn, the proportions of the fire of a deposit which does not contain Explo Control can be seen. When the netting is put in the deposit again, the flames are controlled. Since Explo Control prevents the splashing of nearby deposits, the distance between storage tanks can be reduced, producing major savings in the design of storage installations. Here we can see the safety that Explo Control confers on a 10,000-liter tank of petrol that is filled with burning fuel without any risk of explosion. The deposit is also protected by Explo Control. When the tank suffers from an accident, the flames will only emit from the crack produced by the impact. With Explo Control, the risk of explosion caused by a flechette or an igniter or tracer bullet will disappear. Explo Control prevents burst transfers of fuel and the risk of destabilization of the vehicle transporting the fuel disappears. A tank protected with Explo Control must be correctly filled with the product. Loss in volume is only between 1 and 1.5%. A 100-liter deposit protected by Explo Control can contain 99 liters. Its weight is 0.33 grams per 10 protected liters. Here a test is made with 2 bottles of butane gas protected by Explo Control. When the pressure is increased inside the bottle, the gas is released through the safety valves. The fire darts freed by the bottles overheat the steel in non-refrigerated zones due to the effects of the now evaporated liquid. The aluminum material distributes the heat evenly, preventing hot points and possible explosions. The intense heat has deformed the bottles. Here are 2 bottles without Explo Control. Hot points are produced that weaken the metal. As a rift is produced in the bottle, the liquid butane is overheated, nucleates, and finally results in a boiling liquid expanded vapor explosion. Here we have a butane bottle with Explo Control in an extreme case. The safety valve is sealed off with steel bars that have been bolted down to its gas tap. When pressure is increased due to overheating, the soldering is affected and the gas escapes. The enormous heat generated by 20 liters of petrol and 25 liters of diesel oil increases the pressure yet again, producing the expulsion of the mixture, but not a boiling liquid expanded vapor explosion. Since the contact surface of the fuel inside the bottle with the aluminium is increased by 3,000% thanks to the effect of the netting, the nucleating effect of the fuel is avoided, and thus a boiling liquid expanded vapor explosion. The crack, seal, and deformation of the bottle can be observed. This case is the same as the previous one, but without explo control. After 2 minutes, the bottle cracks. Part of the gas escapes that refrigerated the walls. The material is weakened. A crack is produced due to the enormous pressure, and the boiling liquid violently evaporates. Nucleation. And it comes into contact with oxygen, producing a boiling liquid expanded vapor explosion. Parts of the bottle could be found 200 meters away. The tray was completely destroyed. The energy freed in the violent explosion could completely destroy an apartment where the bottle was situated, together with 4 surrounding apartments. Shots made against bottles containing gas only produce a hole through which the gas escapes, making the valve itself a safety valve. The gas bottles are filled with explo control by a machine created for this effect through an existing orifice before placing the gas tap. The reaction speed is exponential, making the pressure increase inside the city gas piping system in a short period of time, and then producing the explosion, in this case the expulsion of the lid. Here we have a protection system that prevents the advance of the waves produced by gas combustion, avoiding the spread of fire from the protected zones and preventing a chain reaction throughout the pipe system down to the main tank, and thus avoiding an explosion. If an accident were to occur, we would only have to repair the stretch existing between 2 protective systems. Fields of application: gas tanks and developments, plants and butane gas bottles, refineries and chemical plants, aviation, military vehicles, aircraft and vessels, helicopters,
every motor-powered movement,
terrorism and public transport, vehicles and tanks, gas pipelines, oil tankers and fuel transport trains, etc. Reticulated netting production machine for gas pipe protection. Machine for continuous netting production. Once the netting is produced, it is placed in this ball production machine. The process is continuous and a plant can work 24 hours a day with only 2 operators per shift.